Okay, we are going to push away a little bit from those right triangles, and we are going to get very circular. The things that you need to know are a choice had to be made about what was going to be the zero angle. I'm going to draw some rays coming out of the origin. These are all sitting in certain angular positions. What you need to know is the positive x-axis. Humans chose that to be angle 0, 0 degrees. Do you realize humans could have chosen the positive y-axis for 0 degrees, and that would have created a clockwise rotation, but they didn't. They chose the positive x-axis. So that means everything is going to move counterclockwise, because as far as natural motion goes, the fact that quadrant 1 is where x's and y's are all positive means that we must begin in quadrant 1. So if they had chosen, like a clock, the top to be 0, we would go clockwise, but we are not. I repeat, we are not. The positive direction is counterclockwise. And I'm going to point out that if you go halfway into quadrant 1, then what we're looking at is how much of a rotation did that take? Does anyone think they already know? How much degree measure do I have to sweep through to go halfway into quadrant 1?
45 degrees.
Bingo. That is a 45-degree angle. And if I go from 0 degrees, oh, right there, to straight up, that is considered, or that is, 90 degrees. Logic takes over once you get past where is 0 and what direction is positive. So if that's 90 degrees, then what is this angle? If I go from 0 degrees and make half a rotation, how many degree measures is that? 180. Yep. And if I go all the way around and come back to where I started, how many degrees? 360. And I could continue. If I decided that I was going to, let me erase some of this. I could choose to start at 0 degrees and rotate counterclockwise, a full rotation, but then go halfway through quadrant 1 and stop. The full rotation is 360 degrees. Going halfway through quadrant 1 is 45 degrees. So how many degrees is that? You got it.
So you're saying if you go all the way around, plus 45 degrees.
Yep. And that would be 405 degrees. And we could even keep going from there. We could look at, what if I went around once, twice, and then stopped, then if you take how many times you make a full rotation and then add from there what the rotation is based off of just 0, you can get that angle. So what is the angle that I would get if I rotated around 2 full times and then went halfway into quadrant 1? What would that give us? That would be 765 degrees. I can have negative angles as well. So if I start at x equals 0 and I rotate clockwise, I'm actually going in the negative direction. So if I make half a rotation in the negative direction, that is negative 180 degrees. And let me double check. And you can also see here that I've got the vocabulary word initial side. So the ray that is on the positive x-axis of an angle, that is called the initial side of that angle. Then the ray that ends the rotation is called the terminal side. And it's good to be familiar with certain angle measurements. 90 degrees, 180, 270 is 3/4 of the way around, 360. And then I've got here, if you went around twice, if you went backward once, if you went backward twice. So every time you draw a terminal side and you stop it right there, if you don't draw the angle that expresses what rotation it took to get to there, it could be anything. With just the terminal side drawn here, it could be just the rotation in the positive direction less than 1 full rotation. Or it could be a full rotation plus more. Or it could be a negative rotation to get to that point. So just be aware that when you look at a particular ray as a terminal side, unless you draw what the angle is that got you there, it could be a lot of different things. And in fact, there's a formula you can use. Whatever angle this happens to be for my terminal side, I'll just say that's theta. If I want to find what's called a coterminal angle, and I believe that's what I meant here, coterminal angle. A coterminal angle is an angle that shares the same terminal sides. Any two angles or more that share the same terminal side. And if you know one of those angles, let's just say we'll call it theta degrees. If you want to find any other coterminal angles, you're either going to add 360 degrees or you're going to subtract 360 degrees, or you're going to add 360 degrees any number of times or subtract it any number of times. So if n is representing integers, then I don't even need to write the minus sign, but I'll leave it there just to kind of emphasize that it can be plus or it can be minus, where n represents integers. So it could be 0, it could be 1, 2, 3, 4. It could also be -1, -2, -3, those kinds of numbers. That's how you're going to find your coterminal angles. So this is a place where you can draw some of the stuff I was just showing you with positive angle measure, and I'll just show you. These are some of the examples of what you can put on your classwork to help you know those. Do you need me to leave that up for a moment? Okay, I'm going to go ahead and move forward. And this is actually posted with your classwork, so you can look at that also on your own. But now we're going to look at some examples. The directions are asking you to state a negative angle of rotation that is coterminal with the given angle of rotation. So let's start with that, and then we'll move on to what it's asking to sketch. If I have 120 degrees, what do I need to do to find a coterminal angle that is negative? What can I do to 120? Subtract 360 degrees, and you have a calculator. Consider yourself fortunate, because when in-person starts back up, I'm going to push back again with the not using a calculator for everything. I'll just share with you, just so you're aware, the technology is great to use. The drawback in math, if you use the calculator too much, is you don't gain number sense or algebra sense or function sense. That is valuable. And it's just a thing of exercising the mind. And if you become very dependent on calculators, your mind isn't exercising that much. There's a big concern with society's future. I'm sure some of you are aware of the concerns with technology. No? Yes? Or are you just too tired to respond?
Yes.
The too tired to respond was what you said yes to, I think, is what I'm taking online. All right, anyway. Oh, just aware of the concerns.
Yeah, but I think that's how it is for every generation.
Oh, yeah.
I'm sure your parents were worried about technology.
Oh, yes. Oh, yeah. And each generation, it's a little bit scary though, because each generation gets more lenient. And each generation has an exponential excess of what the previous one had. It's definitely different from just normal stuff that humans have experienced. But anyway, what is 120 minus 360? Uh-huh. Yeah. Come on, pen. Obey. Negative 240. Now, the directions are saying sketch an angle of rotation by a solid arc, or sketch the angle of rotation. The angle of rotation is the 120 that was given to you. Then you're going to sketch the negative coterminal angle with a dotted arc. So first of all, you've got to figure out where is 120. If this is 90 degrees and this is 180 degrees, where does 120 lie in there? What fraction in there?
It lies 90 and 180.
Uh-huh. And should I draw it like here? Should I draw it here? Where about should I draw it?
Closer to 90, but
Uh-huh. So one thing to be aware of is how much rotation do you have as you go from 90 to 180? You have a 90-degree amount of rotation going from one to the other. Where is 120 in that? How many degrees past 90 is that? Because what you,
if you cut it up into thirds,
there we go.
that's about 1/3 in.
Mm-hmm.
So it's 1/3 away from 90.
Yes. And 120 is 30 degrees beyond 90. And if you think about this being a 90-degree amount of rotation, 30 degrees is 1/3. So I'm really glad you said 1/3. That was what I was hoping to guide you toward was, and now you're not going to do the most perfect job of cutting a quadrant into thirds. Just do your best with it. And so I've got 2 rays coming out to try and cut that up into 3 congruent angles, but it's not perfect. I'm going to erase, though, this one. And what I'm trying to get going is a sense of where an angle lands. You want to get familiar with your rotations and where certain angles are at. So what it's asking you to do is, if I can get my pen working the way I want it to again. This arc right here, this solid arc with an arrow, and then drawing the terminal side, as well as drawing the initial side. But the biggest issue is drawing that terminal side. This is the drawing of that angle that was given. That's 120 degrees. Now, when it says to sketch the coterminal angle with a dotted arc, I'm going to put that in red just to distinguish. So I'm going to dash backward and then meet at that same line. So negative 240 is starting at 0, heading in the negative direction, and going past 180 degrees, and in fact going 2/3 of a quadrant past 180 degrees. And so that's what you're expected to draw. All right, let's move on to B. If your angle is 108, what is a negative coterminal angle? How do you find a negative coterminal angle? The excitement is just like, oh my gosh, so much excitement for this would be more exciting if we could actually get close to each other and have conversation. Anyway, minus 360, what does that give me?
It makes it so that you go down the
Mm-hmm.
90-degree mark,
Mm-hmm.
so the negative 90-degree mark.
Mm-hmm.
No,
Well,
okay, so back
if, uh-huh. Well, are you describing the 108 or the negative one? Okay. And then you were saying to start at 90?
yeah.
Uh-huh.
So I don't know if the numbers always going to be this nice, but if you add 18 plus 90, that's basically 9 times 2 plus 90. So you know that you can cut this up like into 10 pieces.
Right.
But you won't need to do that because it's 18 not 90.
Right.
Added to 90. So what you do is you move 20 degrees left of the 90 degree mark. Well, basically 150.
Mm-hmm. Excellent. Yeah. And the way you just described that is what I mean by that number sense and angular sense. That's really valuable just for your mind to be able to process. So if I cut this up into about fifths, then maybe that's about a fifth. If you're freehanding this, you are not going to be perfect. On a test, if you have to freehand draw this, here, let me explain what I'm expecting. If you're going to draw a 108-degree angle, I expect you to at least realize that it is within here, somewhere that your ray exists within about that much. So if you can just be within half a quadrant of the correct angular position, I will call that good enough. Just freehanding is not going to give us accuracy, not unless we pull out a whole compass, which we're not going to do. So that right there is approximately 108 degrees. And if I'm drawing that solid arc, I have my initial side, and then this arc with an arrow is explaining what angle took place, that it was in the positive direction and that it was less than one rotation. So now, what is 108 minus 360? Anyone? Uh-huh. Negative 252. So the directions ask you to first state a negative angle of rotation that is coterminal. Then second, sketch the given angle of rotation with a solid arc and the coterminal negative angle with a dotted arc. And then that problem is done. One more, 315 degrees. If I want to find the negative coterminal angle, I'm going to subtract 360. What does that give me? Mm-hmm. And in this case, negative 45 is going to be easier to see its location than 315 degrees. If I go negative 45 degrees, then I'm going halfway down into quadrant 4. So the dashed arc right here is the negative angle of rotation. Then if I'm explaining the angle that is 315, I would start at the positive x-axis and go less than a rotation until I reach that. And you know, after doing the algebra of rational functions, isn't this kind of a refreshing time? We get to draw circles. All right. Now, this time you're getting an angle that is over 360 degrees. So the first thing is you're going to state a positive angle with less than one full rotation that is coterminal with what is given to you. So that's the first thing. So if I have 480 degrees, what do I want to do to find a coterminal angle that's less than it? And I'm guessing some of you are thinking it. Yeah. If I subtract 720, I'll get a negative angle. Yep. So I only need to subtract 360, but what you just said, that's going to be helpful to realize when you have an angle that's over 720, that it's going around more than twice. So what's 480 minus 360? Hey, that sounds familiar. Can you draw a 120 degree angle? So I've got my initial side and my terminal side for 120 is just a third in, a third of the way through quadrant 2. And it's not perfectly drawn here. Now, what's asked of you is just to sketch the given angle. So what I want you to see is subtracting the 360 helps you to figure out where it lands. The fact that you only subtracted 360 one time means that when you draw the angle, it's going to have to make a full rotation, and the only way you're going to draw this nicely is to draw a spiral. and then it continues until it reaches that angle where 120 is terminal with it, or coterminal with it. And that's all you're doing for these problems. So 600 degrees. What is 600 minus 360? Anyone? Anyone? Thank you. That's 240 degrees. And now where would that be? Where is 240 at? Let's remember that this is 90, 180, and you want to actually start memorizing that this is 270. So where is 240 located? How many degrees do I need to add to 240 to reach 270? 30 degrees. So that means if I cut up this quadrant into thirds, approximately, 240 is going to be this one right here. So it's 30 degrees before I hit 270. Now, if I'm going to draw the actual given angle, that is 600 degrees, I have my initial side, and I'm going to make a full round spiraling and continue. And then while I'm on my second round, stop at that position. Now, for 915. If you're aware of 720 being double 360, then you might immediately just subtract 720. But let's say you don't notice. What is 915 minus 360? I know, it's a Monday, and everyone's a little more sleepy on Mondays, aren't they? Yeah. It's so awkward to have a classroom that's so quiet. I'm going to enjoy the too much noise that drives me a little bit crazy by the end of the day. I'm going to appreciate it a little bit more. What is 915 minus 360? You're subtracting 720. And you just said 500. I didn't catch that. Yeah. All right. If that's a number bigger than 360, then you need to subtract 360 again. But I want to say, if you had realized at the beginning that this was larger than 720, you could have just subtracted 720 because that's double 360. So now what is it? And what did you say? I think I heard 195. Okay. So 195 degrees. Now let's think, where is that? Where is 195 degrees? And you want to be really familiar with, these are actually called your quadrangles, the angles at the edges of quadrants. You want to know your quadrangles, 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees. Where is 195 in relationship to these? How much further is it from 180? Do you feel like you're the only one answering? Well, there are a couple of you that are giving answers. What is, how much is 195 over 180? 15 degrees over 180. So you want to think about how much is 15 degrees. And one way you can look at it is, I get 30 degrees when I cut this up into thirds, and 15 degrees is half of 30. So I'm cutting these in half again. And again, I am not doing the ideal job at drawing these. And I don't expect it to be the most perfect angle. But I would say that on a test, I would be looking for it existing somewhere in here. If you can at least give the right half a quadrant, get it in the correct half of a quadrant. And that's good. Good enough. Now, this is asking you to draw the angle though, the original angle. This time we are going around the circle 2 complete times before we make our final run. So starting at angle 0, we go around once, we go around twice, we keep going, and then finally stop. Know that part of today's work is just getting used to the position that an angle lands on. And for your homework, all you're going to do is just more of these problems, not throwing anything else at you. But this circularness, we're going to be connecting it to those right triangles next. So I want to prepare you a little bit for that. By the way, I plan on giving you a quiz tomorrow, not today, because the first day was just some review that should have been stuff you already knew. So I'm going to give you a quiz that's based on 6.1 and 6.2, which basically takes us to 6.2. 6.1 was just reminders of stuff. So you need to be able to, given sides of a triangle, state what sine, cosine, tangent, secant, cosecant, and cotangent are. You need to be able to, with a calculator, find missing sides. With a quiz, though, I'm going to say exactly which side. So you might be given a problem like number 6 here, and maybe I put an x right here on the hypotenuse. If I do that, then you're going to first start with an equation. So let's think about that. Identify your hypotenuse. That's this x number. Identify which of the two legs we are using or given. If this is 64 degrees, this side is opposite. Now you have two options. The one you're most familiar with is sine of the angle measure is equal to the opposite side divided by the hypotenuse, and we're trying to find the hypotenuse. However, you could also have used sine's reciprocal function. Cosecant of 64 degrees allows x to be in the numerator, and some people find that easier to work with. But you do either one, just get a correct answer is all that's required. So you want to start by writing an equation and then let your calculator take over. If you do go about it in this manner, you need to multiply both sides by x, and then to solve you have to finish by dividing. And then with your calculator, you're going to write an answer down. So with this as a quiz problem, you're going to be writing the decimal measure that you get into your Go formative answer. And so those are the things to expect with the quiz tomorrow, is be able to find a missing side using trigonometry. I'm not going to bother with Pythagorean theorem. I want you to show me that you can use your trigonometry to find one missing side if you're given only one side and an angle. And then if you are given sides of a triangle, can you answer what is each of the 6 actually that's showing with different angles, but can you express the sine of A, the cosine of A, the tangent, and the other 3? So that's what you want to make sure you're very clear on. Let's do a quick review just to make sure, because I know that this needs to be reviewed often. And in fact, I think I'm going to come over here. And what I'm going to do is I'm going to draw a triangle. I'm going to draw a right triangle here. And we've got angle theta right there. And this is going to be easiest if I just say this is like a 3, 4, 5. Can you tell me the ratio for sine theta? What is the ratio for sine theta? Opposite over hypotenuse, right? Are you with me? Okay, because I am telling you, you're going to have a much easier time with the rest of this class if you get down these ratios, like really, really well. It will make a huge, huge difference. What is the cosine of theta? The adjacent side over the hypotenuse, right?
Yep.
All right. What is the tangent of theta?
Opposite of radius.
Right? Then, once you have those three, it's really easy to get the other three. Which function is sine's reciprocal? Which is sine's reciprocal? Which trig function? Yeah. Cosecant, which is CSC. Cosecant, just take sine's fraction and flip it around. Who is cosine's reciprocal? Who is cosine's reciprocal? Cosine and sine, it's the opposite of what you want. Yeah, it takes a little bit of getting used to. And wait, I just wrote, why did I? Yeah. Secant, I can do this. And then what is tangent's reciprocal? COT. So CSC for cosecant, SEC for secant, and COT for cotangent. Make sure you feel really good about these 6 trig ratios. It will make a huge difference. All right, it looks like we are just about out of time. I'm going to stop.